As we said before, a rational agent should not only perceive its environment, but also learn it. But what does it mean that a computer learns from its environment? For example, does simply storing the data amount to learning? The answer to this question is no. A computer that stores data is called a database, and it has nothing to do on its own with learning. Instead, learning implies the ability to generalize, that is, to apply to learn enough from the data shown in order to optimally act when presented with new data. Generalization is an ultimate goal of learning. Or we can even say it's meaning of learning, as a way to perform well on tasks on new yet unseen data. Respectively, machine learning is a subfield of AI that studies perception, learning, and action tasks as algorithms that learn from raw data. Machine learning has emerged, or maybe we can even say that it branched off such fields as statistical modeling and dynamic programming as a response to real-world industrial demands that called for methods to effectively handle large and high-dimensional data. Machine learning modernized these fields by focusing on computer algorithms to estimate complex functions that typically cannot be expressed in closed form. In addition, machine learning benefited from many fields such as information theory, computer science, physics, neuroscience, biology, and so on. As a particular subfield of the general AI research, machine learning is used in areas of AI such as natural language processing, knowledge-based systems, and tasks within the realms of the artificial general intelligence. I would also like to remind you the term machine intelligence that I mentioned as a suggested less ambitious term to denote projects in the AI space pursued by AI startups as well as big firms. Now, let's consider in a bit more details what specifically constitutes the difference between traditional statistical modeling and machine learning. Even though it's not easy to draw a hard separation line between the two approaches, we can nevertheless specify some broad categories that differentiate them. First, statistical models generally try to explain the world in terms of relations based on causality. On the contrary, machine learning only tries to mimic the world rather than explain it. It often uses correlations as proxies to causality relations. Respectively, the statistical modeling approach has a pre-specified model of the world that just needs to be estimated. Relations between observables are deduced in this approach. Differently, relations between observables are induced in the machine learning approach. This is because it does not have any a priori pre-specified model of the world and instead focuses on the predictive power. Furthermore, statistical models typically deal with small data with up to 100 attributes and up to thousands of examples, typically. On the other side, machine learning sometimes deal with data that might have the number of attributes in hundreds of thousands and the number of examples in hundreds of millions. Because of these differences, while scalability is normally not a major concern for statistical modeling approaches, it sometimes becomes critical in machine learning applications. Finally, I would like to mention that while statistical modeling is based on probabilistic approach, some machine learning methods, including support vector machines, neural nets, and some clustering methods, are non-probabilistic. Now, it's time to introduce the main diagram of machine learning. Recall a diagram from the previous video that showed the agent and the environment. Let me now replace the name agent by the name ML algorithm and draw these two elements again. A concise and operational definition of machine learning as a process of learning is given in 1997 book of Mitchell. It goes as follows. It says a computer program is set to learn from experience E with respect to some class of tasks T and performance measure P if its performance at tasks in T as measured by P improves with experience E. So adding these three elements to our diagram, we can now view it as a general description of the process of machine learning. But what about these T, E, and P? We need to specify in more details what we mean by task T, performance measure P, and experience E. And this is what we're going to do next.